Okay, great. Yeah, thanks. Thanks so much. This is my fourth year attending the Syniode conference, and so this is I've presented on WikiModel before, and so I'm presenting it again this year. And I'm happy to announce that I've made some major improvements have been made to the software. So let's go ahead and get started. So what is WikiModel? It's a free web-based software tool for simulating and fitting models. You don't have to do any programming. You just enter equations as they appear in a textbook. You don't have to download or install anything that runs on your browser. And it sends information from your computer or your tablet or your smartphone to the cloud, and it does the processing and returns the results. It handles any number of differential equations and or closed form equations, and it plots the simulated results on the screen, and it can handle discrete inputs, and it can also fit your model to experimental data at and the times for the data can be sparse. And also the models and the data are shareable in a library for collaboration. So just a quick history on WikiModel. It's sort of something I started many years ago, and I released it, first version of it.
No, no, I
wanted to say something about it.
In 2017. And so it's sort of it's a self-funded project that I worked on for over many nights to get it to what it is today. So and I've done many updates, especially in the graphical user interface. And I'm happy to announce that in October of last year, I released software. I released a new version that had user interface and enhancements, where there's now when a user types in any errors, you'll get some feedback on where the error is. Before this release, when there was an error typed in by a user, sort of the program would just you'd get this spinning loading symbol, and it would just last for a while and then return with nothing. So that was, I think, a little bit frustrating for users, and so I put in the resources necessary to have a better user interface. In addition, the plots are zoomable and synced, and you don't have to specify what you want to plot. If it's left empty, it'll plot something by default. And you can now copy and paste data from spreadsheets into the table when you want to fit your models to that data. And it has a more robust, you can upload your WikiModel if you don't want to use the user interface, and there's a more robust way of uploading the data. And also, I've recently integrated recently allowed ChatGPT to learn how to create WikiModel files, and that you can immediately upload and simulate them into the software. So we'll go ahead and what I wanted to do first is sort of demonstrate a previous example that I gave at a different Syniode webinar back in 2024. This model is actually created by Brian Winkle, and I've already created the model in WikiModel. So I'll go ahead and click that, and it'll bring up the model. And what you could see is I've again described WikiModel many times before, so I want to focus on the improvements. But if this is your first time on this website, it's free to use, and you can create a profile and start using it immediately. On the left-hand side, there's lots of preloaded examples that you can load that are available to the public. And so this is just one of them. And so this is a model where, and I've got the sort of a description of the model here. It's a two-compartment pharmacokinetic model where LSD is injected intravenously into the plasma, and then it travels to a remote compartment. And so you have two equations. I also have a constant variable, which is the ratio of the two spaces, the tissue space to the plasma space. And so what you'll see is that what is also plotted is the plasma concentration and the remote the LSD concentration in the plasma in the first plot, and the LSD concentration in the tissue in the second plot. And what you also see is experimental data here, and the experimental data is you can type it in here, and what you'll see is that the modeled plasma LSD concentration in the plasma doesn't go through the data, but what you can do is you can fit the data. So if I want to I'm fitting my plasma concentration to my data P1, which is in this data tab, and when you hit the fit model button, you'll see that, hey, now the simulated plasma profile goes through the data because I fit it. And what you'll see is if I go back to the model tab, it'll tell me what my fit parameters are. But I wanted to highlight sort of what happens if somebody types in something incorrectly. So for example, here, this is a two-compartment model, but let's say instead of T here, I typed in Q. Now it doesn't know what Q is because it's probably the person made a mistake. So if you try to simulate that, it will say invalid part Q, and at the bottom it says the red portion of equation 2 has an error. Please revise and try again. So let's go back. So if I go back and type in T, it'll work. So now it works. But let's say there's an error somewhere else. Like if I put some letters, no, my data table can only contain numbers, but let's say I typed in a Y here by accident, and then I tried to fit that. It says, it tells you that there's a mistake in exactly where the mistake is located. And it says there's an error in this table, so you have to fix that. So all that is nice. Now let me fit the model again. So another feature that's new is you can zoom in on the data points. Notice that even if you don't zoom in, it'll tell you what the data point is that you're looking at on any of the plots. And what's cool is you can also zoom in, which I didn't have this feature before. You can zoom in, and notice that when I zoom in on the top axis, it's synced that the second axis is zoomed into that same time range. So if there's another plot that has the same X variable that you're plotting against, it'll sync the two zooms. And to go back, you could just hit I think it's the home button, reset axis. It goes back to where it was, and you can actually export the pictures. You can download any of the graphs by hitting that, and it'll save it to your computer. Let me check the time. So I wanted to show some new features. So back to my slide, I wanted to show that how you can integrate ChatGPT with WikiModel so that you can create models from prompts, and WikiModel will create this file that you can upload directly into WikiModel to simulate. So here's sort of an exercise that I tried, and I first asked it create a WikiModel file with a system of equations that simulates cruise control for a car starting at 30 miles per hour, where the set point speed is set to 60. So it actually before this, actually, I I trained ChatGPT by uploading the WikiModel application instructions, and from that it learned sort of how do I create a file that I can upload, and it learned how to do that. I also gave it 12 examples to learn from. So, but this is a new problem. I never gave it this to learn from. I just asked it create a WikiModel workspace file with a system of equations that simulates cruise control for a car starting at 30 miles per hour, where the set point speed is 60. So it actually, what I noticed is that when I gave it the instructions, I actually asked this question in a different thread, and so it didn't know what I was talking about. And so what I noticed is that I had to go back to my original thread where it learned sort of everything that I told it about my application. So once I did that, it gave me this file. And so it gave me this text file. I upload it into WikiModel, and you can do that by go back to. You could do that by going here. You could do upload workspace from tab-delimited text file. So when you do that, when I did that, it gave me this, and it came up with a model, and it said, "Hey, look, I started from 30, and I set my set point to 60." And eventually the car, yeah, it reaches 60 miles an hour, and it chose that it wanted to plot the velocity of the car as well as the throttle. And these are the equations that it came up with, and the parameters that are in these equations with these parameters that it made up, which is really cool because I never said, hey, I want these to be the equations. All I did was I gave it that prompt that I wanted a set of system of equations to simulate a cruise control for a car, and it did it. Now you do notice that the speed actually goes below what we started with, and then goes to 60, and we'll talk about that a little bit later, and you'll see that I will address it in my next follow-up prompts. So then I said, okay, well, it came up with this equation, said the rate of change or velocity over with respect to time, aka acceleration, is 1 over tau times throttle minus velocity. So that's just Newton's second law, right? But I asked it sort of what is tau, and I kind of had a suspicion of what it was, but I thought I'd ask that question. So I said, I asked the question, what is tau? And it said tau is the time constant vehicle of the speed response, and then it said it's a function of mass, and then it said, I thought it said it's a function of mass somewhere. I think it did. And then it said, if you'd like, I can generate a slightly more realistic cruise control model where tau is derived, oh, here it is, from the mass. And it also added this, this drag force that was proportionate to velocity squared, and another drag force that was proportionate to velocity. So I'm just responding to its what it said. If you like, I could generate a slightly more realistic cruise control model. So I said, sure. I said, yes, please. Again, give it to me in a downloadable workspace text file that I can upload to WikiModel. So then it generated this text file, which I downloaded and then uploaded into WikiModel. And then it gave me this. And then I noticed, hey, there's something weird here, because now my cruise controller, instead of going from 30 to 60 like it did before, it went from 30 to like 22. And I was trying to figure out why in the world did it do that? And it chose to plot all these plots in 3 different plots by itself, but it didn't plot F command. So what it's showing is there's two engine forces here. One is what it wants the engine to do, but what it did in this equation here is it actually saturated the range so that the command can't be less than 0, right? The engine force can't be less than 0, and it can't be greater than F max, and it picked an F max of 4,000, right? And I noticed that the force it was trying to generate was always greater than 4,000. And for that reason, it didn't work, right? So then and so I sort of figured out that it had to use different parameters and different in order to get the cruise controller to work. So then I followed up my question with that, and I said, hey, I can't even read what I wrote now because my shared screen tab is sort of covering what I had. Oh, I could see it here on my other screen. So I basically said, your calculated F command is changing over time, but it's always greater than your set F max of 4,000. So I said, well, it sounds like maybe you can try, perhaps your parameters need to be adjusted. And then I asked it to add that F command to the second plot. Can you give me a new improved downloadable workspace file? So then it's thought for 27 seconds, and then it says, you're exactly right, la da da. My resistance term was larger than F max, even at 30 miles an hour, so the car had to slow down. I fixed that by changing the parameters, essentially. Then it gave me a new file, and then I tried it, and it worked. So here's what the new file looked like. So none of the equations changed. It didn't change any of the equations. It just changed the parameters here, and you could see that it worked, right? And it's really cool. It's showing the velocity, the force, and the error. So it's using it's using a PI feedback controller, and it's a function of the error. It generates what the force of the engine is. So then I asked the question. Hey, what are the units that you used? And can you give me the units for all the equations and all the parameters? And it said, sure. And so that's what it did. It gave me for every equation what the units were, and for every parameter what the units were, which I thought was really cool. And then I asked the question, I brought up the point that, hey, realistically, since the car starts at steady state at 30 miles an hour, you can't have because based on the initial conditions it gave, it makes the assumption that the engine started at rest. Now that can't happen because my speed initially was 30 miles an hour, not 0. And because of that, it has to start my integrator term here. So if I go back, you'll see this initial value for my integrator is 0, which translates to that initial force had to be 0 before even time 0. So I basically said, hey, from the two equations, you have to calculate an I term that's non-zero, because the initial force is not, can't be 0. So, and it actually used those two equations that I brought up, and it calculated a new initial value term for my integrator, and it came up, and I asked for it to give it to me as a function of my parameters. So it's saying, hey, when you use the cruise control of your car, that's exactly what your cruise controller does. Is it initializes this I term to whatever speed as a function of whatever speed you are traveling before you turned on the cruise controller, and then it worked. So I'm just showing this as sort of, I think WikiModel's already easy to use, and you don't need ChatGPT to do it. You could just start the application, and from scratch you can use a whole bunch of pre-saved models in the library. But I think this use of ChatGPT will further lower the barrier to using the application and getting your students learning. And maybe as a teacher, you could create a problem. You can create math problems or science problems with ChatGPT as an assistant. Now, I will say that, as you could see, it's still, some of the assumptions it did were maybe not the best. And so I still think, your job as a science or math teacher is safe, because it's still not as smart as you, and you still need few iterations to get maybe to get the model parameters right and to get but I think, it still helps a lot, and it lowers the barrier to entry. Um, and what I noticed is that just because I had it trained for me, you can't just go into your chat GPT and say, hey, make me a WikiModel workspace file that does this model, because what it learned on my in my environment is not going to carry on to yours. So, and I kind of realized that the hard way, but basically what you can do to get it to work for you is you can download the instructions from the WikiModel page, which is through this link, and then
just a heads up that there's only a couple minutes left in the
okay. And then you could type in this text prompt, and then you can ask it to generate a model for you and upload that file. And that's really what I wanted to share. But again, if you've never heard of WikiModel, it's free, and I encourage you to try it. There's no license and no downloads or anything. I wanted to thank the folks here. Preddy is the guy who implemented all those UI feature improvements where if you type in an error, it gives you feedback, and it gives you it lets you cut and paste the data into the data table. And Tova Brown actually used WikiModel in her classroom, and her students used it. Now, at that time, I didn't have all these cool features with the improvements, so I think there was, and I got some of that feedback, and so I used that, and I made it I think more user friendly. And Amit is co-founded developed this application with me, and Gary is my first was a mentor I had that got me started in this whole mathematical modeling, specifically of ODEs. And I want to thank Brian and everybody for attending my talk. And I just hope that you give it a try. If you have any questions, you can email me. If you go to the WikiModel website, it'll have the instructions. The instructions under the About page. You can contact me. You can contact me or send me an email at sami@wikimodel.com, SAMI@wikimodel.com. You can also contact me through this page. But yeah, you can sign on for an account and give it a try. Let me know what you think. Thank you very much.